so this is going to be pH 111, chapter 3, which we're going to be talking about vectors. So let's define what a vector is. Now, there are two types of vectors or physical quantities. There's scalar quantities that the direction does not matter, such as time. If I tell you what time it is, it's 5 o'clock, 3 o'clock, 12 o'clock. All right. If I put you upside down, what time it is, direction doesn't matter. It's still the same time. 3, 5, 12 o'clock, whatever. Vector quantities have both magnitude and direction, such as vector, velocity, acceleration, force, momentum. So let's say if you're going out to the right, you're moving to the right, and I give you a force going in the same direction to the right that you're going. Then what's going to happen? You're going to increase your speed. But if you're going to the right and I give you a force opposite of your direction, let's say to the left, you're going to decrease your speed. So the direction matters for vector quantities. Now, a vector can be represented by an arrowhead line whose length is proportional to the magnitude of some quantity and whose direction is that of that quantity. You're going to put an arrow on top of the variable. So let's go ahead and watch this little video about vectors. I have it right over here. Now notice each vector has two resultants, your x component and your y component, which we're going to be talking about that in just a second. But like this one has a y component, x component. All right. Now, when you add vectors, we use a method called head to tail. So we must account for the magnitude and direction, and we place the tail of one vector to the head of the second vector. Now let's watch this little video about this. Now, that's what we're going to do by Pythagorean theorem. So the Pythagorean theorem, again, you've probably seen it 100 times, which is your hypotenuse square, c squared is going to equal to a squared plus b squared. So let's say we got this question. You're going up, you're going north for 5 kilometers and east for 3 kilometers. What is your resultant? So let's go ahead. So in this matter, your A, that's your 5 kilometers, and your B is going to be your 3 kilometers. We're looking for your C vector. So your C squared is going to equal to your A squared plus B squared, which is going to equal to your, which is going to make it, C is going to equal to the square root of A squared plus B squared, which is going to equal to your 5 squared plus 3 squared, and you're going to get 5 squared is 25, 3 squared is 9, and you're going to get the square root of 34. Square root of 34, that means it's closer to 35, which is going to be about almost 5.4 kilometers. Let's go ahead and check. Yep, 5.8 kilometers. I did this by my head. All right, 5.8 kilometers. Now, so we actually looked right now at the video. Go ahead and get another one. So let's say if you have, your magnitude of A direction, you get your magnitude of B direction, and we said that we do head to tail, and that will be your C direction. Well, let's go, this is displacement, so we're gonna call it S. Follow your book for displacement. And you're gonna be seeing that a lot further. So your S displacement is gonna equal to your magnitude of A plus your magnitude of your B. Now, some of the properties that vectors have that, let me just go ahead. Black over here. So your vector addition is commutative. Is commutative. What does that mean? That means your A plus B is going to equal to your B plus A. So let's say if you have a vector A, I'm going to have vector B. Okay. So your resultant of these, that's going to be your A plus B. Don't forget the arrows for your vectors. Now let's say you reverse this action. Let's say this is your vector B over here and going on to vector A. So this is your B, this is your A, this is going to be your B. It just appeared. B, A. Let me get a green. Let me get a red on this. For that, you won't get that. Here it is. This is going to be B plus A. Same thing. I try to put them on top of each other. Now, it's also associative. So vector addition is associative. What does that mean? That means you got vector A plus vector B, and you compare it with vector C. It's going to be the same thing as A plus B plus C. So let's do an example, shall we? So let's say we get the magnitude of A was 3 meters. The magnitude of B was 4 meters. Find the maximum values for A. For C, okay, so let's do A. Find max value for A. B. Find the minimum value for A. Not A, I'm sorry, for C. Well, for part A, what you're gonna have? Your C is gonna equal your A plus B, which is gonna equal to your 3 plus 4, which is gonna equal to 7 meters. Now, for the minimum value, what you're gonna do, you're gonna be subtracting, doing the opposite. So your C is gonna equal to your 4 minus 3, which is gonna equal to your 1 meters. Now, from the video that we had a little while ago, so you had, let me say this is my axis over here, and I get a resultant component that we see in the video. This resultant component, let's call it A. Now, this resultant is because your A component in the y direction, A component in the A direction. So this is your y direction, A component in the y direction, and this is your A component in the x direction. And let's say this is the angle between them. So the angle cosine theta, again, is going to equal to your side plus over the hypotenuse. Or in this case, we like say it's the x. And again, your A, let me get a different color on this. So here's your component for the x. So this is going to be the same thing as this one. Here's your component for the y. So this is going to be the same as this one. Cosine theta is going to be your x component over hypotenuse, which is going to be our A vector. So that means your AX equals cosine theta multiplied by A. Same thing for sine theta is your y component over hypotenuse. So it's going to be your AY is going to be your A sine theta. Your tan theta is going to equal to your AX over your AY. And your resultant, using the Pythagorean theorem, for the magnitude of A is going to equal to your AX squared plus your AY squared. Now, let's go ahead. I want to go define something called the dot product. See, the dot product, and I'm pretty sure you've seen in your calculus class, it has on vectors A and B, and it doesn't matter. It goes in any dimension n. Or like the cross product, like I'm going to see, goes for any dimension, for 3 dimensions. Actually, let me just define the cross product. Cross product happens only in 3 dimensions. Now, the resultant of your dot product is going to always be a scalar. The resultant of a cross product is going to be a vector. So let's take a look at the dot product first. So let's say you have 2 components. So you say component, I don't know, call it V, which is going to equal to, I don't know, V1, V2, V3, we said whatever you want, you can go all the way down to Vn. And you got your component W. Let's say this is W1, W2, W3, all the way, you can have up into n dimensions, so Wn. So V dot W, what that's going to equal to? Your V1, W1, plus V2, W2, plus V3, W3, etc., plus your Vn, Wn. Well, let's reverse it. If we reversed it, V dot W, sorry, not V dot W, W dot V, that's going to equal to your W1, V1, plus W2, V2, plus W3, V3, plus whatever it is Wn, Vn. So your VW is going to equal your WV. And again, this is a computative. Ability or property. Now, the angle between them is your A dot B. When you actually do that, the angle between them, so let's say you have actually, let me just get a different color. Go this over here. Yeah, this one over here going in between theta. So you wanna do the dot product between two of these vectors. So for this one, let's say this is A. The component of the B vector along the direction of A is going to equal to, let me get a different color for this. This is going to be B cosine theta. And if you actually look at the B vector, the component of the A vector along the direction of B is going to equal to, let me go ahead and write this in a different color also, A cosine theta. Now, having these two, and again, we're not going to go through the derivation of the mathematics on it, but your A dot B is going to equal to your magnitude of A multiplied by your magnitude of B cosine the angle between them. Now with the dot product, let me write this down, dot product. The order does not matter. Now, your B cosine theta that we actually have would be the magnitude of vector B that goes in the direction of A. And vice versa. Let me go ahead and write this down. Your A cosine theta would be the magnitude of vector A that goes in the direction of B. Now you're going to end up with a number. When you do that, you're going to end up with a number. And again, it's going to be a scalar. That's about the dot product. Now let's go with the cross product. Actually, let me also copy this. So the cross product, we said, only goes in 3 dimensions, and the answer is always going to be a vector. So what does that mean? So let's say you have your A component, which is going to be, we said it's going to have to be only 3 dimensions, your I, your J, your K. So this is your A1, this is your A2, this is your A3. and your B vector, which is going to be your B1, B2, B3. Now let's do the A cross B vectors. What's going to happen? Now, you're going to have your I, your J, your K values. Your first one is going to be for A's, A1, A2, A3, whatever the value is A. And then for B vector, you're going to have whatever value for B1, B2, and B3. Now, the rule is the first one, you go in the I direction. So when you go in the I direction, you hide everything that has the I. So both of these go away. So what you have, A2, A3 minus A3, B2. So A2, B3 minus A3, B2 in the I direction minus the J direction. So minus in the J direction, you hide the J. So what you get, A1, B3 minus A3, B1. A1, B3 minus A3, B1 in the J direction plus the K direction. These goes away. So what you get, A1, B2 minus A2, B1. In the K direction. So let's say if we had, let's do an example. Let's say we had A is going to equal to 1 minus 7 and 1, and your B is going to equal, let me get different colors for these. Go back to black. A is going to equal to 1 minus 7 and 1. And your B is going to equal to your 5, 2, and 4. Having A cross B, I, J, and K, 1 minus 7 and 1, 5, 2, and 4. What you're going to have? You're going to have these two. So this is a 4 over here. So that's going to be minus 28. Minus 2 in the I direction, minus you hide the J direction, which you're going to have. So with the J's, what you got? You got 1 times 4 is 4 minus 1 times 5, which is 5, plus your K direction, which is going to be 2 plus this. So here's your K's, 1, 2 minus 35 in the K direction. So this is going to equal to, I don't know why is this messing up, having technical difficulties. So this is going to equal to minus 30 in the I direction. Now you got 4 minus 5 minus 1 plus 1. So you get what's plus J in the J direction. Plus these two are going to be added. So 35 plus 2 is 37 in the K direction. So your answer would be minus 31 and 37. That's your A cross B vector. Now, the angle, so if you have, let's say, you get these two vectors. Let's say this is your A vector, this is your B vector, and this is going to be your cross product, A cross B. Now, A cross B is going to be orthogonal, okay? Let me actually go ahead and write that down. I did not even write that down. Let me go ahead and actually write this down. So in the A direction, be A2 B3 minus A3. What happened? There's a button on my pen that always keeps on pressing and stopping the recording. B2. This is A3 B1 minus A1 B3 minus this is going to be A1 B3 minus A3 B1. And this is going to be positive A1 B2 minus A2 B1. And again, this is going to be orthogonal to A and B. So because it's orthogonal, using the right-hand rule, what you can do, so let's say this is your thumb, beginning finger, go in here, this one goes all the way down. All right, I think that's a good drawing. So let me just put this, and this is your thumb. So this is going to be your A cross B. This is going to be your B component that we have over here. And this is going to be your A component. Now, again, there's an angle between them. The angle in a cross product, A cross B, is going to equal to your magnitude of A multiplied by your magnitude of absolute value of B multiplied by sine the angle between them. Now, the magnitude, if we define the magnitude of X, length is going to be x1 squared plus x2 squared plus x3 squared plus whatever it is, x and the square. So let's say you had A cross B. You want to find the magnitude squared. What's that going to equal to? It's going to equal to your, again, going back to our old one, what you're going to have. Go ahead and copy this one. That way we can actually use it. A cross B, magnitude squared is going to equal, now let's take the first term. Now, remember when we had A plus B squared is going to equal to A squared plus B squared plus 2AB. A minus B squared is going to equal to your A squared plus B squared minus 2AB. We're going to be doing this over here. So this one is going to actually equal to, and let me get black color over here. Your A2 B3 minus your B3 go ahead and just copy this back. See this? All right. So A cross B squared, you get all of this squared. So we're gonna square this one, and square this one. Okay, let me actually take these out. It's easier to write it that way. So if you open it, what you're gonna have? You're gonna have A2B3 squared minus 2A3B2B3 plus A3 squared B 2 squared plus or not plus, minus A1 B3 squared minus actually I think it'd be easier, I just looked at it right now, if we actually get rid of the negative. So what we're gonna do, let me just take this out. Just to make it the math easier, just get rid of all the negatives. What we're gonna do, this is gonna equal to A3 B3 minus B A2 B3 minus A3 B2 squared let's open this up. So this is going to be minus plus, we just reverse the order, be A3 B1 minus A1 B3 squared plus A1 B2 minus A2 B1 squared. And that way we get rid of the negative sign over there. So this would actually make it a lot easier to open up. So opening this up, what you're gonna have? You're gonna have A2 squared B3 squared minus 2A2 A3 B2 B3 plus A3 squared B2 squared plus you got this little fellow over here. It's gonna be A3 B1 squares minus 2A1 A3 B1 B3 plus A1 squared B3 squared plus A1 squared B2 squared minus 2A1 A2 B1 B2 plus A2 squared B1 squared. Now, solving this, and again, hopefully you like math, this all thing is gonna equal to. We go ahead. So let's do the A1s first. So you get A1, multiply, you get B2 and B3. So B2 squared, B3 plus B3 squared. These are looking like an H. Here's your ones. Now we do A2 for B1 and B3. So plus A2 squared for B1 squared plus B3 squared. Plus the third one for A2, A3, B1 and B2. So you get A3 squared, B1 squared plus B2 squared. And you get minus, minus, minus. So let's take negative 2 as common. So what you have, A2, A3, B2, B3, plus A1, A3, B1, B3, plus A1, A2, B1, B2. And let's call this equation 1. Now let's do the same thing for, let's open on another page, for the dot product. So let's say you need the dot product squared. So A dot B squared. What's that going to be? And again, A is A1, A2, A3. And let's say B was your B1, B2, B3. So A dot B squared is going to be equal A1, B1 plus A2, B2 plus A3, whatever the value for B3, squared up. So what this means is your A1, B1 squares actually maybe go ahead and write it down so we won't make a mistake. A1, B1 plus A2, B2 plus A3, B3 multiplied, or yeah, by A1, B1 plus A2, B2 plus A3, B3. It's just easier to visualize like that. So what you have, plus A1, A2, B1, B2 plus A1, A3, B1, B3. Plus A1, A2, B1, B2 plus A2, B2 squares plus A2, A3, B2, B3 plus A1, A3, B1, B3 plus A3, B3, they both squared, plus A2, A3, B2, B3. Now let's organize them a little bit. So you got A1, B1 squares. Go ahead and get rid of this one. A2, B2 squared and A3, B3 squared. A2 squared, B2 squared plus A3 squared, B3 squared. Plus, what you got? You got A1, A2, B1, B2. You get A1, A2, B1, B2. There's two of those. There's A1, 3, A1, 3, A2, 3, A3. So there's two of each, if you notice. So this is going to equal to 2 times, the first one's A1, A2, B1, B2. So you're supposed to have 2 of those. And then you got A1, A3, B1, B3. A1, A3, B1, B3 plus. You get A2, A3, B2, B3. A2, A3, B2, B3. Oof, that was a long equation. Let's call this equation number 2. Now let's add equation 1 plus equation 2, which again, this is for A cross B, your magnitude squared. This is A dot B, your magnitude squared. So what do we have? Actually, let me go put this in a new window. So 1 plus equation 2. So what you're gonna have, if you combine them, you get A1 squared, you get B1 plus B2 plus B3, they're all squared up, plus A2 squared for B1 squared plus B2 squared plus B3 squared, plus A3 squared for B1 squared plus B2 squared plus B3 squared. Now, on equation 2, we have plus 2, A1, A2, B1, B2, A1, A3, B2, B1, B3, A2, B3, B2, B3. In equation 1, we actually had the opposite. So this is going to be positive, this is going to be negative, this is going to be negative, this is going to be positive, they're both going to go away. So this is what you got, the resultant. So this is going to equal to, what we can do, we can assess them where it's going to be B1 plus B2 plus B3 squared, squared, squared times A1, A2, A3 squared, squared, squared. And remember when we defined the magnitude of x is x1, x2, x3. So the magnitude, this is going to actually be the magnitude of b squared. And this is going to be the magnitude of a squared. So a cross b squared plus a dot b squared. What's that going to equal to you? A cross b squared plus a dot b, we said what's going to be a squared b squared cosine squared theta. And again, this is equal to what? To your magnitude of b squared times magnitude of a squared. So a cross b squared is going to equal to your magnitude. So looking at this one over here, this is going to be the magnitude of b squared, a squared, minus this term over here, your a squared, b squared, cosine squared theta. So if you take these as common, what you're going to have? You're going to have your a squared, your b squared common. So this divided by this is going to be 1 minus cosine squared theta, which is a cross b squared. But if you remember from trig, cosine squared theta plus sine squared theta is going to equal to 1. So sine squared theta is going to equal to 1 minus cosine square theta, which that's all we have. So this is actually sine cosine, is going to be sine square theta. So your A cross B square is going to equal the magnitude of A square, so the value magnitude B square sine theta squared. Take the square root of all sides. So what you're going to have, you're going to have A cross B is going to equal to your magnitude of A, magnitude of B, sine theta. So the cross product is going to equal to your magnitude of the first one times the magnitude of that second one multiplied by the sine of the angle between them. And that should conclude chapter 3 for Physics 111. If you have any questions, just email me at abunaem@uih.edu, or you can give me a call at 256-348-1480. Thank you.